class. This is the start of Unit 4, Linear Relationships and Slope. And the first thing we are going to talk about today is slope of a line. All right, so our learning intentions, right, is going to be able to find the slope of a line. And you know you have it when you can find slope via a graph, through a table, and by using the equation on 2 points. All right, so you're going to need to be able to find slope in 3 different ways in this section. Let's see how we do that. Well, actually, first, let's describe slope. All right, it's just how steep is the line, right? I'm going to let you read that, but that's essentially it. How steep is the line? And we find slope by finding the rise, right, the vertical change up and down, over the run, the horizontal change left and right. So it's going to be a fraction 99% of the time. Unless we're talking about money, then you can put it in a decimal, but usually we want slope in fractions. And here we see that slope can be positive or negative. And that just depends on, how it looks. So let's get into slope. Let's see if we can start finding some slopes. All right, so our first example, we are going to find the slope of this line by using these 2 points, right? This point here at 0, 2, and this point here at 3, 5. All right, so let's see how we can find slope using a graph. Well, first we're going to count the run. How many spaces to the right do we have to go to get from one dot to another dot? Well, in this case, it's 1, 2, 3 spaces to the right. And from there, how many spaces up do we have to go to get from one dot to the other dot? And in this case, it's 1, 2 spaces up. So our rise is 2, our run is 3. Therefore, slope, which we use m to signify slope, that will be 2 over 3, rise over run. So 2 over 3, 2/3. That is the slope of this entire line. All right, so if you're watching the video, I want you to find the slope of this line on your own. Pause the graph, count from this dot to this dot. How much do you go down and how much do you go to the right? I'll give you a hint because you're counting down this time, right? Your rise is negative. So just a little hint for your slope. So pause it, try to find it on your own. All right, if you counted correctly, you went down 4 spaces. 1, 2, 3, 4. That's a -4, and you went right to the 1. So -4 over 1 simplifies to just -4. Yes, you will want to simplify your fractions still. So you're either going to end up with a whole number or a fraction. I do not want mixed number slopes. That would be very confusing. You don't want to do that to yourself. So either leave it as an improper fraction or simplify to a whole number if you can. All right, so here we're going to find slope of a line from a table, right? The second thing we need to figure out how to do. So here we have our x values of -6, -2, 2, and 6. And we have our y values of -2, -1, 0, and 1. So to find slope from this, we just have to find the rate of change, right? How much it's changing from one point to another. So our x value is changing from -6 to -2. Well, that's +4. And from -2 to 2, that is also +4. And from 2 to 6, well, that's also +4. So we have a constant change in our x value, our run, of 4. Now let's go to do the same thing for our y's. From -2 to -1, well, that's +1. From -1 to 0, +1. From 0 to 1, guess what? +1. So our constant change in y value is 1. So our slope should equal 1 over 4. Our rise is 1, and our run is 4, so 1 over 4. And you would just leave that as 1/4 because that's as simple as it gets. I would not recommend putting that in the decimal 0.25. That would make graphing more confusing. The fractions make it easier if you need to turn this into a graph. And we'll see that later in the section or in the unit. And once again, this is just a prettier version of what we just did, so you can take some notes, so pause it here if you need to. And then that's how we found the slope from a table. All right, here's your check problem where I want you to try to find the slope from the table on your own. Remember though, slope equals rise over run, and your y value is your rise, and your x values are your run. So the little hint there, try to find the rate of change, tell me what the slope is. All right, pause it here and try to find the slope. All right, you'll see if you found the slope correctly, it is 1/2. And if you're ever confused about one of these check problems, bring these into class and ask me or Mr. Lowell. That'll help clarify anything. All right, here's where we're going to learn the last way to find slope, which is by using the formula, right? Slope equals y2 minus y1 over x2 minus x1, where x2 doesn't equal x1. I mean, technically, don't worry about that. Because that's just talking about, if this is true, we're just talking about undefined slope, which we're going to talk about later in this video. So just, you don't even need to worry about that, honestly. Worry about this, right? M equals y2 minus y1 over x2 minus x1. And all that means is you subtract your y's on top, and on the bottom, you subtract your x's. The only thing you have to make sure is that you are consistent which ones are your x2s and y2s and x1s and y1s, right? Because if you mix them up, that's the only way you'll get this wrong. As long as you keep the correct x and the correct y with each other, you're fine. All right, so here's the formula we're going to use up top. Once again, it's y2 minus y1 over x2 minus x1, and we're going to get those points, right? x1 and y1 from like S, and x2 and y2 from point R. We're just going to plug in the values, so let's go ahead and do that. So once again, here we're plugging in our values, right? We get x2 from point R, the value of 1, and then we get -4, which is x1 from point S here, and then we just have -1 minus -4. And on top we have y2, which is the value of 2 from point R, minus y1, the value of 3 from point S, and we just plug that into our formula. So we have 2 minus 3 over 1 minus -4. So when we do that math, we get 2 minus 3 is -1 over minus a negative is a positive, right? That's plus. So is 1 plus 4 is 5. So our slope ends up being -1 over 5. And that makes sense because this line does go down from left to right, meaning it should have a negative slope. So there you have it. And if you also wanted to double check, you could use your count method because you do have a graph, right? You went down 1, so your rise is -1, and you went 1, 2, 3, 4, 5 to the right. So yeah, using the graphical method, you can confirm your formula method, the slope is -1 over 5. All right, here you are going to use the slope formula, which is m equals y2 minus y1 over x2 minus x1. All right, just go ahead and plug in your values and find your slope. Answer is on the next slide, so pause it here and try to find the slope on your own. Is the step-by-step solution to your check problem. Hopefully you paused it and tried it on your own, even though I know you probably didn't. But here's the answer anyways. So you should have gotten -3/4 for your slope. All right, last two things to talk about, right? Your slope of a horizontal line, we've already talked about this in class, is 0, right? So easiest way to remember that, horizons are horizontal. You see that? Slope 0. And lastly, up and down lines, that is your undefined slope. If you're using your slope formula and you get an error, that means undefined. All right? So that's section 4.2 in a nutshell. Slope. Have fun.